Did you finish? If someone is still writing, let me know. You can put a thumb in the description. Okay, all of you finish. Okay, let's move to next part. Next one is about the motion in a straight line. This is little bit difficult because we are moving to a physics part. But if you listen carefully, you can easily understand all the theory parts here. There are some small calculations here, but don't worry, you will be able to solve all the questions if you follow correct instructions here. Okay, listen carefully. In this physics part, we are discussing about the motion in straight lines. You can see lots of objects moving here and there. Some objects move very fast, some are moving very slowly, and some objects move by changing their directions, but some objects, they move without changing their directions. These things are learned in this part. Okay, at the beginning, I would like to tell you that there are some physical quantities to learn here. Basically, we can divide these physical quantities into two parts. They are known as scalar quantities and vector quantities. I will explain what is the definition for scalar quantities and vector quantities. Scalar quantities are known as the physical quantities with a magnitude, but they have no specific direction, certain direction. I will explain. If you move from your home to school, then that distance belongs to scalar quantities because you are moving without a certain direction. You can understand that when you start to move, you need to turn left, right, again left, again right. Likewise, you are moving with turnings. So there is no specific direction. But if you can move from your home to school without turning your direction, without turning your moving direction straightly, then that has a certain direction, specific direction. That is called vector quantity. I will explain about the vector quantities. First one, definition. Vector quantities are known as the physical quantities with a magnitude and a specific direction. We can simply say the physical quantities with a magnitude and a direction are known as vector quantities. So if you can refer this diagram carefully, from A to B there is a straight line. This straight line has an arrowhead. This arrowhead is pointing towards B from A. So this object moves from A to B towards a certain direction, that is the direction of B. But the other paths, path A, path B, like paths, they have no specific direction, because when you are moving through path 1, the object needs to move to left, again to right, likewise. That is the difference. So let's move to the summary about these scalar quantities and vector quantities. Scalar quantities are known as the physical quantities with a magnitude only. It has no specific direction. But vector quantities, they have a magnitude and a specific direction. Next one, about the examples for scalar quantities and vector quantities. Basically, distance belongs to scalar quantities. I will explain about the distance. Distance is the length of the path taken by the object. Suppose again you are moving from your home to school. Then the length of the path is known as the distance. Distance is measured in meters and it is a scalar quantity. And the other thing, if you can move from your home to school straightly without any turning, that is called displacement. Again, there's a distance or there's a length between your home and school. But here we are measuring the shortest length between your home and school. That shortest length or shortest distance between your home and school is known as the displacement. So when you are measuring the distance, you are not considering about a certain direction, about the direction. But when you are measuring the displacement, you have to consider about the direction. That's the difference. So distance belongs to scalar quantities, displacement belongs to vector quantities.